Welcome to our talk about Redis Graph, a low latency graph database. My name is Cailliau. I am a product manager at Redis Labs, and amongst other modules, I'm product managing RedisGraph. So the talk today is structured in the following way. I'll give a brief high-level overview about RedisGraph, and then we'll talk a bit more about use cases, and to talk into more details about the specific use case, we'll bring on Matt Rodkey on stage to talk about their multi-cloud offering platform at IBM. Then the last part, we'll talk about what's coming up, which feature are we currently developing, and we'll talk about, we'll bring on Sebastian Heimann from Linkurious, who will show effectively what those new features are enabling inside RedisGraph. Let's start off with this chart. This chart is created by DB Engines. DB Engine is tracking the popularity changes across different database models. So we can see here, they're measuring it since 2013, January 2013. We can see clearly that graph database management systems are in the lift, right? We can also notice from this chart that relational databases are steadily decreasing in their popularity, steady but slowly. What is a graph? A graph is in a mathematical form is a collection of vertices and edges. And the model we're using inside RedisGraph is a property graph. And we have four building blocks there, right? So we have nodes and relationships, labels and relationship types, and properties. So the nodes are effectively our vertices. The relationships are edges. They're always directed and connect two single separate nodes. And labels can be placed on top of nodes. Each node can have 0 or multiple labels. And each relationship has exactly one relationship type. Properties can be placed both on nodes and relationships. So let's look at an example graph here. So the node on the left has a labeled database. It has a property, the key name and the value RedisGraph. And then there's a relationship going to Cypher. So we support Cypher from 2016. The node representing Cypher has a label query language and has a property name and a value Cypher. So the property on top of the relationship is effectively used in this kind of a way to version your graph. It could be used in a different way. It could be used to quantify the strength of a relationship. So for example, if we'd have a relationship that does likes, but you can love somebody, you can like somebody, so you can quantify the strength of your relationship with a property on top of that. The properties on top of a node typically are used to describe the entity. They could, it could be metadata on top of your entity. So in this case, they effectively describe your node. What is a graph database? It's effectively a database with a graph API on top of that. So a graph API allows you to query to do CRUD operations on top of this graph model. In the most simplistic form, we could go ahead and we could create a graph database on top of a relational database, right? If it would take the first table, which represents the nodes, and the second table that represents our relationships, and the relationships effectively is two columns pointing to two foreign keys of your nodes. That's it. We kind of like have more or less a graph database model. And what is the downside of this is effectively that when you would traverse, what we call a traversal, when you do a hop from one node to the other node, it will always imply an index lookup. So that's why we want to make a clear distinction between graph databases and graph native databases. So a graph native database is a graph database that also has index-free adjacency. And this is effectively why this is important for us, because at Redis Labs, all the stuff we do with all the modules, we always want to categorize them under high throughput and low latency use cases. And that's no different in the case of RedisGraph. We want to be the fastest, highest throughput graph database out there that gives you the lowest latency. So for this, effectively, the data structures underneath inside RedisGraph, we chose for adjacency matrices. But there are two common ways to solve this problem. It could be either via an adjacency list and an adjacency matrix. So in an adjacency list, you keep a list of all the nodes. So you keep, with each node, you keep a list of all the outgoing relationships that it's directly connected to. There's one downside with this is that you never have like a global view of your entire graph. Adjacency matrix effectively is a square matrix where each row and each column represents all your nodes within your graph. And when you have a relationship in between two nodes, we add one value at that location. So in this case, for example, this one represents the relationship between node 1 and node 2. I'm not going to talk too much more about this into details. If you want to hear more about that, Roy Lippman, sitting in the audience, is going to do a deep dive tomorrow and talk much more about the internals of RedisGraph. I do want to touch upon two concerns that you could have with this adjacency matrix problem. The first one is the space complexity, right? So such a matrix can become very large. However, most graphs in our world are quite sparse, right? If you look at the social graph, Facebook has 1 billion users. However, only on average, each user has 400 friends. So there will be a lot of zero values in there. And there's a concept which is called sparse matrices. So it allows you to effectively compress that matrix into a more optimal data structure, which reduces your space complexity to the same as an adjacency list approach. The reason why it hasn't been done before is we don't see a lot of graph databases with adjacency matrices under the hood is because there was no efficient way to calculate linear algebraic operations on top of those sparse matrices without decompressing them into their full-blown form. So that's why we're using GraphBLAST, which is a highly optimized library to do linear algebraic operations on top of those sparse matrices. And that's as far as I'm going to go on a technical level. We'll talk more about the implementations tomorrow. Last thing I wanted to touch upon is Cypher. So Cypher is our graph API, so where we can do CRUD operations with. It's an open standard. It's supported by several graph databases. I like to explain it as in a comparison with SQL, right? So it allows you to focus on what rather than how. I always had the feeling in SQL you had to construct your query to instruct SQL how to retrieve your data. Do this join on this table with this primary key to equal to that foreign key. You never have to do that again in Cypher. You can effectively focus on what you want to retrieve. And it does that by matching certain patterns in your database. And each pattern is going to be sent into a pipeline that you can effectively do further operations upon. And these patterns we describe by what we call the ASCII art for graphs. So nodes are represented by parentheses, and relationships are represented by -- greater than. So you can see an example on the graph I just showed you. In this query, we're matching a node that has the label database and the property name equal to RedisGraph. And we're going to do a one-hop traversal, and we're going to return the relationship type of R, the type of the relationship, and the name of the property. So for those who have been paying attention, the response of this would be support Cypher and written by Redis Labs. That would be the response of this query. So what did we do since we went GA? We effectively went general available in November last year. And we've been working about many things in parallel, and just want to give you a brief overview of those. So Cypher, we've been trying to close the gap to support more and more common graph use cases, right? So in the initial GA, we had let's say the minimum viable product of Cypher that we were supporting, but now we're kind of like closing the gap and getting more feature complete to support the full query language. We added faster and better bulk loading. So if you want to start with RedisGraph, you can effectively start with a set of CSV files and do a massive initial import into RedisGraph. We added several performance improvements. I'm not going to touch too much details, but in certain type of queries, we can get up to 3 times performance improvement on top of the initial benchmarks we already published before. We also enabled a higher write throughput by taking more granular locks on our matrices. And we worked on a smaller memory footprint. It says compressed properties is more or less effectively it's encoding the keys of our properties that we're doing. And in certain scenarios, we can get effectively 30% less memory footprint for certain graphs. In that way, we'll be continuing working on those stuff, obviously, in the future. So I wanted to talk briefly about our community. This is a screenshot taken last week. So we had more or less 100 unique cloners and 3,000 page views. We're really seeing an increase in the community. And since we went GA, also two new clients were added on top of the 6 client libraries we already support in the most common programming language. The PHP driver and JavaScript driver had been added by people outside of Redis. We also closed 102 issues. 56 are still open. You could say that's a bad thing, a good thing. I believe it's a good thing because it shows effectively that our project is being used and people are effectively trying things out. It also has been pulled over 10,000 times from Docker. So we don't know. I think the next one is 100K plus. So we were somewhere in between. It could be 99K at this moment. Let's assume it's 99K. And one of those examples of these issues that I wanted to highlight, just as an example, is somebody's asking for integration for GraphQL. So for those who know GraphQL, the API language created by Facebook, I think. Don't quote me on this. It's effectively, there is kind of like a stack full of components and adapters that you can create a GraphQL API on top of a graph database out of the box. And this guy wants to work on an adapter to do this with RedisGraph. So that will allow you to create a GraphQL API very quickly. Use cases. So common use cases for graphs, social, recommendations, customer 360, fraud prevention, master data management, network and data center management. I could talk for an hour about those, but I'm not going to do that. What I rather like to do is kind of like give you an abstraction. Given the fact that you have a use case, and RedisGraph is now a tool in your toolbox, you've just been educated in very lot of details. You have a use case and you would like to consider, is this a good use case for using RedisGraph? So the way you could do that is by kind of like scoring your use case, and typically I do that in 4 dimensions. The first dimension is your data transactional. If your data is static, you have a static data set. For example, you import all the bones in your body and you want to find the shortest spot between your nose and your toe. It's a good use case, but the data set is static. It's not changing. Do you need a database for that? It becomes much more interesting if your data is continuously changing, for example, and you want to make a real-time query or all at the peak time or queries on top of that data. The second one is it synchronous or real-time? Is there a real-time need? The easiest way to explain this could be fraud prevention versus fraud detection. So in fraud detection, you would find a pattern in the graph, and then asynchronously somebody is going to investigate that pattern, right, inside your graph database. In fraud prevention, we want to prevent that transaction from happening real time. So some process is idle while waiting for that. So we need a performance, we need a high throughput, low latency database. Graphs are also schema-less. So if you plan to do your project in an agile way, you tend to add multiple data sources, kind of like in a custom 360 example, for example. You would like to start with a simple data set. You would like to add more and more data sets. You don't have to define your schema up front. You can just let your schema evolve over time because there are no restrictions there. And the last one is the most obvious one. It's a complex query, right? So if you would have an entity you would like to relate to 4 other entities, or you would like to do a graph search, a shortest spot in between 2 nodes, which is kind of like a quite expensive operation on other databases, obviously that makes your case stronger. So I'm not saying you need all of these 4 dimensions, but the more you have, the stronger your case is to use a graph database. And with that, effectively, I would like to call on stage Matt Rodke. So Matt Rodke is Principal Offering Manager at IBM, and they're using, almost in production, I think, RedisGraph for their multi-cloud manager, and he'll talk more about that.
Thank you very much, Peter. So I'll get into, as Peter said, I'm Principal Offering Manager at IBM, and we built a product called IBM Multi-Cloud Manager. I'll talk a little bit about why we built the product, and then I'll get into why we chose to use RedisGraph and why we felt we needed a graph database. And actually, it lines up really nicely with the 4 dimensions of the use cases you just showed, even though I'd never seen that chart before. So one of the things that we started noticing when we talk to our clients is that customers are using more than one cloud. And there's a number of different reasons why people are using more than one cloud. Some of them are for development purposes, where there's an affinity to services that may be present on one cloud and not another cloud in their catalog. Others are for a mix of a more traditional hybrid sense, where they're doing on-prem workloads as well as public cloud workloads. And then we're increasingly also seeing a little bit of people looking to diversify and not put all their eggs in one single cloud basket, just from a risk management perspective, sort of at a certain level. But what's really interesting is, well, 98% of these clients are saying, hey, they're using multiple clouds. Only a third have any kind of a plan to figure out how they can manage all those things together. So we realize that as organizations start to scale up to this level, they got to figure out a way to do management across multiple clouds. And that's sort of where we came in with trying to build IBM Multi-Cloud Manager. We're very focused. IBM is very big on containers and Kubernetes as the mechanism for delivering these workloads across multiple clouds. So we built a stack here that starts sort of at the bottom with choose your infrastructure, right? Are you running on OpenStack or VMware at the IaaS level? Are you running IaaS on any one of the public clouds? Are you a choice of Kubernetes layer, right? Kubernetes is actually rapidly becoming commoditized in the same way that Linux is becoming commoditized. Pick your favorite distribution and run your workloads on top of it. And where we really start to add value is we said you need to be able to have a set of overarching core operational services across all this stuff. And then that's fed by an enterprise content catalog. And while I won't get into it because it's not the use case here, actually Redis content is part of that content catalog that we ship. So we ship a content catalog of certified packages for Kubernetes delivered by Helm charts onto all these different clouds, which includes IBM's commercial software stack, as well as third-party commercial software stacks, and as well as open source software stacks. So we built this thing, and we started to pull in a bunch of different clusters. Some customers have up to 100 clusters. And when we started to look at the turn of the crank for phase 2, we said, when they're doing this core operational stuff and someone needs to go solve a problem, figure out, really simple thing, I've got an application that spans multiple clusters. How can I go figure out where the failed pods are for that application, which may be across multiple clouds? So a pretty classic sort of a graph problem like we just talked about. So it is a fairly complex data set that's pretty dynamic when it comes to Kubernetes, that scales in, scales out, spins up, spins down. And it's now spanning multiple Kubernetes stacks, perhaps running on multiple clouds. And I need to quickly get to the answer of what's failed so I can go fix it. So I'm going to skip this one and get in more into the use cases. So this is where we brought in, we decided we need to build a search interface that says, how can I go and query all of that stuff? So I need all of the things that are related to my application, whether that be stateful sets, deployments, persistent volumes, pods, the relationships between those things. And I need to quickly go find something, and then once you found it, go take an action on it. So we build a nice graph with all these relationships, and then we build in actions that allow someone to go remediate that from a central hub. And we actually tried several graph database technologies, and we really found that Redis was really the one that gave us the speed that we needed to be able to, these are the sort of real-time instant problems that people need to solve. And Redis was really the one that gave us the speed. And we actually found it interesting using, notably because we're using Cypher, we were easily able to switch in a single development sprint, actually a 2-week development sprint, between GraphDB technologies underneath. So we were doing these tests, and it was really easy for us to port our work sitting on top of it between these different ones, which was really nice for us. It allowed us to do some experimentation, side-by-side testing, before really kind of settling on what we really wanted to do. And sort of talk a little bit, I'll get into a use case here a little bit with it, but just here's sort of the view of what we do. So we have multiple managed Kubernetes clusters, leveraging Kubernetes APIs to pull data, and Tiller for deploying Helm charts out onto those. We aggregate that data up on another Kubernetes cluster that we call the hub, right? So it's a hub and spoke type model. And then we build a graph with all these relationships here in real time. We have role-based access control in front, so we have teams of people that can build and share and save queries between each other. And we can hide queries from other folks, but they can also share them amongst their teams, which is very nice. And you sort of see in some of the dotted line feature bits here, we know that this set of data that we're going to pull in through these collectors is only going to grow as we get into more interesting use cases around maybe things that are outside of Kubernetes. So you have a Kubernetes application that talks to a virtual machine somewhere, or a mainframe somewhere. We are IBM. We've got a lot of customers that run things back on a mainframe somewhere. So are there other bits that can build out that graph around an application, a deployment, that are interesting? And as Peter pointed out before, the notion that we didn't have to build a schema up front, we can just add those data collectors in as they grow and build these relationships out here was really attractive to us for this type of model. Mostly what we're looking at is real-time type models here, but I think we are going to perhaps get into some of those fraud detection type models in the, or fraud prevention type models, where you're doing it, you're maybe real time making a decision or blocking a transaction. We're not doing anything with that now. But again, we also, right now we have a UI up here, and we also have sort of CLIs and APIs where we may even put other stacked things on top of this solution as well from IBM. But we really found, you're sort of to net it out here, that using RedisGraph, we quickly, from hundreds of clusters, we can go and find and save this query, see the answers. We can find that needle in the haystack where that problem is. So with that, I think that's my last chart here. I'm going to pass it back over. Peter, you coming back up to chat for a minute? Awesome. I'll pass it back over to you.
Thank you, Matt. Thank you. Thank you for talking. That's a fantastic use case for RedisGraph, and I like how you compare it to the dimensions that I mentioned earlier. So, a couple of minutes I'll be talking about what's next, or what's upcoming. So there are three features I want to talk about, and those three features will effectively tie into the next presenter, Sebastian, who will talk about what it effectively enables for you. The first one is Graph API. So Cypher is great, but what if you would like to run, for example, a Graph global query? So Cypher is more ideal for you find a certain node within your database, and then you crawl around that node within your graph. But for example, a PageRank algorithm is going to run over your entire graph, and you want to find the most connected node, for example. So can you access these adjacency matrices, the power that we have effectively inside RedisGraph directly? Currently you can't, but we want to expose that to you. What if my traversal logic is too complex? It could be that you could express it in Cypher, but your Cypher query becomes quite long, and it might not be that in each scenario we create the most ideal, the most optimized execution plan for that. So you would like to have like a low-level C API where you could implement your complex traversal logic. And what if a function is not there yet, right? So although we're closing the gap, it could be that there's a function not there yet available for you in Cypher and you would like to use it. So we're going to expose that for you, and we're actually really excited about this feature because this feature is going to allow, it's going to make RedisGraph even more usable, and we think it will generate even more adoption, and the community can effectively contribute, creating new algorithms, just as node centrality, in-betweenness, etc., and PageRank. They can be developed by the community and they can be shared by other users. So how it would look like to be decided, but the idea would be that you could, for example, dynamically load a shared object into RedisGraph, and then you could call it either via Cypher directly, so as a stored procedure, you could call it from within Cypher, or you could call it separately with a separate command that we would call graph.call, for example, here, where we would call the PageRank algorithm on top of our wiki graph. We could also look at user-defined functions. So in this example, we're looking at a sign function that is implemented and loaded into this separate shared library. The next feature, we've talked about it this morning in the keynote, is the combination of search and graph. So this will effectively allow you to do a graph-aided search. And by the way, this feature is available as preview as of today. So what is graph-aided search? So as the most intuitive or common example that you could think about is your LinkedIn search. You're effectively searching for a person in a full-text search index, and then you're ordering the results based upon your personal connections within that graph, right? So we can see if I search for our CTO, after 3 letters I already find Yiftach to be my first connection. And the query could look something like this. So we're effectively calling our full-text search index. On the people index, we're going to search for a fuzzy match on Yif. We're going to yield the nodes, and then we're going to find a pattern between that node and myself, assuming that I have ID 1 in the LinkedIn database. And then we're going to order those results based upon the length of the path. And the shorter the path is, the higher the results should be. The third feature I want to talk about is our full graph response. So once again, back to our example graph. Nothing changed so far. RedisGraph is still being developed by Redis Labs and is supporting Cypher. So if we would execute a query currently in the Redis CLI, this is how the response could look like. So we're matching a pattern where there's a relationship between 2 nodes, a simple pattern, and we're returning the name property on the first node, the relationship, and the node M. So the full relationship and the full node M. However, when we look at the response, it's quite tabular. What we'll see is we'll see the properties. It will create a column per property on that relationship and on that node. So the first one is the name property, which is RedisGraph. The response is there. And then the from property is there 2016. And then there is Cypher, which is the name property on resulting end node. There are a couple of shortcomings with this, right? So if you would, from the client side, you would do, for example, you would query a subgraph and you would get a response. You can't reconnect the dots. You can't say, okay, this is this node and I will relate it to the other node via this relationship. There's another shortcoming that is if we would return the full example graph that I showed you before, you could see there's a null value showing up, the one with last row. This is because there is no from property on the written by Redis Labs relationships, right? On that relationship, there is no from property, so it's going to show you null value. Now, in the small graph, it's not so much of a problem, but you have lots of relationships, lots of properties, lots of relationship types. You're going to get lots of null values. So what we're doing, we're going to, it's effectively also available as preview. As of today, we now have a full graph response format. And in this graph response, we'll have separate type of objects. We'll have either a property object, we'll have a node object, a relationship, or a path object that we will return. And to give you an example how this could look like, within the same query, we'll still return the name, but now we'll return R and M, which are their relationship and our node. And there's just a response example of the second array that I want to show you. Of the type, the example is a relationship, so we can see that it now has a field, which is a type, which is supports as a relationship type. We can also see the source node, the destination node. We can see the properties on top of this relationship. So it's going to be much more descriptive. Your clients can consume this information and can effectively either construct kind of like object graph mapping objects on the client side, but it also enables visualization, right? You could now reconstruct that graph and make it visual to represent it. I stripped off the node response, but now you could argue that that response would be creating lots of overhead just for the beautifulness to show it in your Redis CLI. So we also have a compact version that is to be used by our clients. And in this compact version, we're going to send an encoding, right? So we're going to send all the property names, the relationship types, and the labels. We're going to send them up front. And then the response will effectively will be an encoding. So the first response or the first column will be a property, which is type 1. Then there will be a relationship, which is type 3 of an object. And then there's a node, which is type 2 of an object. And then all the rest is kind of like encoded to have like the minimum amount of data that we need to send over the wire to do this efficiently. So to recap, what we're currently working on is the Graph API, the graph-aided search, and the full graph response. And to show what that could enable, and enables, I'm calling Sebastian Heijman onto stage, which is the CEO and co-founder of Linkurious.
So today I will talk about the point of view of the end users. At Linkurious, we create software that helps business analysts to detect and investigate suspicious activities in complex datasets. And to do so, we have created the Graph Intelligence platform. The problem for our analysts is that companies already have a lot of data, but it is hard to make sense and get access. So usually you have data scattered in different databases, and the problem is that it's really hard to get access to. So when companies want to fix that problem, they usually hit performance and usability issues. So what we can provide with graph technology today, the problem with the situation that we've seen is that companies can difficultly adapt to that problem. With the situation we have seen so far, we have these different problems. First, investigators will lose a lot of fraud because they can fail to identify the different connections between entities, so they will fail to assess the different risks. So this is a blind spot problem. Then, as data is difficult to access, they will also take a lot of time to make investigations. Investigations can take days sometimes. And it really hurts the bottom line of companies, as typical companies lose from 5 to 10% of revenues on fraud or compliance alone. So with graph technology, we are able to make it easier to store and query large complex data sets. So imagine that tomorrow you are able to eliminate blind spots and reduce the time spent by an order of magnitude. This is what graph databases like Redis combined with graph visualization software with Linkurious can provide. So this kind of approach was reserved so far to spy agencies, and it is now accessible to everyone to better fight complex threats. from an analyst point of view, it can be difficult to understand a complex situation. So when they are looking for specific threats, they will try to connect the dots between seemingly good customers that we see on the left and maybe potential fraudsters. So they will merge the metadata and try to identify shared connections from orders, credit cards, address, whatever they can, to identify something that looks suspicious to their mind. And this is where the combination of graph databases and visualization software comes from. So at Linkurious, we provide a plug-and-play software that will connect to graph databases, and it will help investigators to explore the data sets as they are looking for suspicious connections, complex patterns that they may have never seen before. And they're able to automate, after that, the detection of such suspicious patterns to run it on complex data sets and make it much faster to investigate. So Linkurious today connects to various databases, and we are very proud to support very soon RedisGraph. We also provide a JavaScript graph visualization library that will help you build products that will integrate graph visualization for your specific interface. Either you are fighting for fraud or doing master data management. Today you are able to quickly integrate graph visualization in a few days into web-based products. And this technology can scale to 100,000 of nodes and edges on screen and provide a nice user interface to investigate. Tomorrow, don't miss the keynote because we will demonstrate a demo that we've made in a few days with Ogma, RedisGraph, and Redis Search on a specific use case. So the typical use cases that we face at Linkurious are fighting fraud, identifying money laundering, working with the intelligence community, and identifying cyber threats. And as of today, we have worked with more than 60 organizations worldwide, from government agencies to financial institutions. Let's now have a look at 4 different use cases that we have done so far with various partners. First, I want to talk about the integration of Ogma, our graph visualization library, into an existing product sold to a government agency. The government had a problem to identify collusion in public tenders. And tender is usually used to generate foster competition between companies to access public markets. The problem is when you don't see that multiple companies are not really competing against each other, but are colluding because maybe they are controlled by the same owner. So how do you identify that? You will create a graph where you will connect those companies to maybe their address, administrators, or even shareholders to identify potential collusion. And this software is in production in a government in Europe today. Another use case is in fraud, in insurance fraud. So the special investigation unit at Zurich Insurance had a backend to handle different claims, and they had a role-based engine to identify potential issues. It was great to spot individual fraudsters, but they couldn't see organized crime. So they connected their backend to Linkurious Enterprise and a graph database to better explore the relationships between the different parties involved in such claims. And by seeing the whole, they were able to spot fraud rings. Another use case here in the banking system. So Before Bank is a French online bank, and they are growing very fast. The problem is that their fraud team cannot hire as fast as they would like. So they want to become more efficient in identifying phishing activities, for instance. So they wanted to link payment transactions with IP addresses, and the problem is that the data was scattered into different databases. So they merged all this data into a graph database and used Linkurious Enterprise to quickly investigate potential suspicious activities, and they're able to make it 10 times faster. And finally, I want to talk about American Enterprise Institute, which is a think tank that provides public reports on global threats for the US, especially in the Middle East. So they have a team of 40 analysts that gather intelligence from open sources such as media coverage and social networks. The data was really difficult to consume for analysts, so they automated the creation of visualization using Linkers Enterprise and Python scripts. So how does it work under the hood? To make it easy, you can connect either Linkers Enterprise or OGMA into a graph database. And basically, you configure a bit, and that works. So we will have a specific demo related to OGMA tomorrow on Keynote. Don't forget about it. If you here see a bit more under the hood, the idea is to provide graph data accessible from a web browser. So to do so, you could either use your own backend or use our Linkerius server that will make it easy to integrate authentication, also security layer, with graph database and graph search. And you will be able to store visualization, make people collaborate on their data easily, and audit what's going on. So if you want to integrate graph visualization today in your product, it's already possible with the OGMA graph visualization library and RedisGraph. And we will support RedisGraph for Linkers Enterprise by the end of the year. Thank you very much.
Thank you. Thank you, Sebastian, for this talk. I really appreciate you coming over. And I'm really excited about working further together on this partnership. So, last question that we could ask: when is all this going to be GA? Right. So all the features that I've been talking about and that effectively Sebastian demonstrated that he could use, we plan to do them hopefully early in the second half of 2019, so you could start playing around with them. But by the way, some of them are already available as preview in our branch. So effectively, it's a RedisConf branch that it's available. So with that, I would like to thank you.